Hi everyone, welcome to part 1 of Learning Through Making, where we will have fun with electric circuit through applying science and mathematics knowledge and skills and the engineering design process in making a product. In this video, we will learn to apply the concept of parallel circuit in making a product and apply the engineering design process in making. We will also learn to solve problems in the process of making. Yes, sometimes things do not go according to our plans. Problems arise, and we have to stop to solve the problem before we continue. Let us recap what engineering design process is. EDP is a series of steps engineers follow to solve problems. It is also an integrator of science and mathematics in STEM education as an approach. The first step is to ask and define the problem. This project starts with a situation problem. Well, sleep and rest are vital for health. After a long day of work or online study, it is good to wind down and relax before going to bed instead of playing games and watching TV. And like to have a cool and relaxing ambience of her room before she sleeps. Her room is a bit too bright to sleep, but if lights are turned off, it is too dark. Sometimes her corner is a bit hot and stuffy. Well, what simple parallel circuit product can we make to enhance the ambience of her room? Now, next step is to research and gather information. In a parallel circuit, the components are arranged in a parallel manner that shares the same voltage with the batteries. However, the amount of current is divided between the two components. Well, let's look at the problem in Anne's room. The room is either too bright or too dark before she sleeps, and sometimes she feels a bit stuffy and hot. She needs something dim and maybe cooling to provide a relaxing ambience to her room. I also need to consider some of the product's constraints, such as the cost, availability of material, and difficulty. Now, we will imagine the possible solution and start to plan. After consideration, I think a simple portable fairy light with a fan seems to fit the requirement and the constraints that we have. Now, let us sketch the schematic diagram. I will use two AA-sized batteries to supply a power of 3 volts to the circuit. Fairy light will be assembled parallel to the fan. I will use a recycled plastic bottle for the design as it is easily available, stable, transparent, and handy. I will also use a fairy light that has a battery casing and switch for easy assembly. I'm using a 3-volt DC motor to power the fan. Let us move on to create our product. We need a used plastic bottle, 1 set of fairy lights that comes with a battery casing and a switch, 2 AA batteries, a 3-volt DC motor, fan blades, and wires for this project. Before constructing the product, I assemble the circuit to check if all the components are working. However, when I assembled the fairy light and the DC motor in parallel, only the motor worked while the fairy light could not be lit. What happened? Well, I have to move on and communicate these findings and choose either to give up or solve the problem. I'll choose to solve this problem because I will learn new things through problem solving. We want to ask why the 3-volt DC motor and the fairy light cannot work in a 3-volt parallel circuit. The voltage is supposed to be sufficient for both devices in the parallel setting. Voltage is the amount of potential energy between 2 points in a circuit. It is like a pressure that pushes water through the hose. However, in a parallel circuit, the amount of current is divided between the two devices. Current is the flow of electrons in a circuit. It is like the flow of water in a hose. In this case, I will presume maybe the current is not sufficient. So now, what should we do to solve the problem? How can we increase the current? Are there other ways? Well, after gathering more information, there are a few possible options. First, we can use 2 sets of batteries to operate the devices separately. Is it possible? Yes, it is possible. However, this will not be economical because we have to use 4 batteries, and also the design will appear to be bulky and not that user-friendly. The second option is to use a regulator to distribute the current evenly. So this component will control and distribute the current to each device. However, it will be a bit complicated. I don't have the expertise to actually handle this component. Third, we can also consider a series circuit. In a series circuit, the voltage is divided, but each component will receive the same amount of current. Let us try. I'll use a high voltage battery, for example, a 9-volt battery, and assemble the components in series. Well, it seems possible. However, the fairy light may not withstand the high voltage in the long run. To solve this, we may need to put a resistor to reduce the voltage. The fourth option is to use a low voltage and current motor. Well, let us check on the first one. Okay, according to the specification, the voltage requirement is 3 volt to 6 volts, and it has a no load speed of 16,000 RPM rotation per minute at 0.7 ampere. 0.7 ampere is the current requirement. And this DC motor, the voltage requirement is 3 to 6 volt. That is 17,000 RPM at 0.35 ampere to 0.4 ampere. That's the current. And this particular motor seems to be the lowest. Yeah? So it only requires 1.5 to 6 volt of voltage, and it has a no load speed of 3,500 RPM at 0.025 ampere. This motor seems to require less voltage and current. Let us try this motor in a parallel manner with the fairy light. Well, it worked. However, the rotation of the fan seems to be slower. So now I have 4 options with their pros and cons. Which one should I choose? Well, stay tuned for part 2 of learning through making to know which option will I choose. See you!